Hi everybody, this is Miss Welch, and today is going to be lesson 2.1.7. Students will practice simplifying algebraic expressions using algebra tiles and will use an expression comparison mat to determine which of the two expressions is greater. Students will also learn how to record their work in order to show their solution steps. Today, you will continue to compare expressions as you strengthen your simplification strategies. At the same time, you will work with your class to find ways to record your work so that another student can follow your strategies. Problem 2-63. Use algebra tiles to build the expressions below on an expression comparison mat. Use legal simplification moves to determine which expression is greater, if possible. If it is not possible to tell which expression is greater, please explain why. I am going to do just example A for this. Question 2-63, letter A. I'm going to start with building both of the expressions. I've got 3x, and then the opposite of 2 and a minus x plus 1. And the other expression mat, I've got the opposite of 5 plus 4x plus 4. I'm going to try and simplify this to see if I can figure out whether the left side or the right side is bigger than the other one. First thing that I have noticed that I like to do first is I like to get everything out of the opposite region. So I bring it up and make it the opposite of. I'll do that over here also, both sides. Now that everything is the positive region, I'm going to get rid of 0 pairs. I've got a 0 pair there, so those can go. I've got a 0 pair there, so those two can go. There's another 0 pair. Another 0 pair. And another 0 pair. So all of my 0 pairs are gone. Now I can remove things that are identical that are in the same region. So I've got a positive x there on the left and a positive x on the right. They will cancel each other out. And do that again. All of the x's cancel out. I can also do that with my negative ones. There's a negative 1 in each section. I can cancel those out. Because everything canceled out, these two expressions are equal and neither one is greater than the other one. Question 2-64, recording your work. Although using algebra tiles can make some things easier because you get to see and touch the math, it can be difficult to remember what you did to solve a problem unless you take good notes. Use the simplification strategies you have learned to determine which expression on the expression comparison mat at right is greater. Record each step as instructed by your teacher. Also, record the simplified expression that remains after each move. This will be a written record of how you solved this problem. Discuss with your team what the best way is to record your moves. Explore using the 2-64 Student E-tool. Here in problem 2-64 is that on the left mat in the positive region, I've got a negative 2x, a positive 1, and a negative 3. And in the opposite region, I have a negative x and a positive 3. On the right mat, I see that I have a positive 2 and a negative 3 in the plus region, And in the opposite region, I have a positive x and a -2. Now what I am going to do is I'm going to flip all of my tiles from the opposite region up to the top region and change their sign by clicking on each one once. Okay, now that everything is in the opposite side, I have, on the positive side, I now have -2x in the left-hand side on the positive region, -2x +1, -3, a plus x, and a -3 is what I changed up there. On the right-hand side in the positive region, I had the 2 and the -3, and now I've changed the x to a -x and a +2. And then I'm going to remove my 0 pairs. I've got a +1 and a -1 there. I'm going to remove them. A positive x and a -x. Oops. Going to remove them. +1 and a -1. Remove them. So now what I'm left with on the left-hand side in the positive region, I have got a -x and -5. On the, oops, I'm sorry, I've got more 0 pairs to do. All right. Get those 0 pairs out of there. Now on the left-hand side, I've got a -x and -5 in the positive region. And on the right-hand side, I've got a -x and a +1. So now what I'm going to do is remove identical tiles that are on the same, in the same region, but on opposite mats. I've got a -x and a -x that are both in the positive region. I can remove both of those. And now I have nothing left that's in common that I can move. On the left-hand mat in the positive region, I've got -5. On the right side of the mat, in the positive region, I've got a +1. And -5 is less than +1, so my right side is greater. Problem 2-65. While Athena was comparing the expressions shown at the right, she was called out of the classroom. When her teammates needed help, they looked at her paper and saw the work shown below. Unfortunately, she had forgotten to explain her simplification steps. Can you help them find out what Athena did to each new set of expressions? You can explore using the 2-65 Student E-Tool. Here I see the original expression for the left side, 3x plus 4 minus x minus -2 plus x squared. And the right expression is -1 plus 2x, -1 plus x squared plus 4x, and the opposite of 4 plus 2x. To figure out what Athena did to go from one step to the next step, what I like to do is just kind of see what is the same and see if I can figure out what changed. So for these, it looks like what changed is there's no longer an x squared on each side. So what she had done is she had removed the x squared tile from each side. Then I'm going to go to the next part and see what is different. The change is right here. So she had gotten rid of the parentheses. What she did is flipped the tiles from the opposite region into the plus region. Next section. Got those combined and those combined. And on the right hand side, the x's were combined and the constants were combined. So Athena had combined like terms and removed all the 0 pairs. After that, what I notice is that it just has the 6 and just has the -5. What Athena had done, what Athena had done is remove 2x from each side. Now I've got 6 on the left expression and -5 on the right expression. And because 6 is greater than -5, the left side is greater. Please make sure that you look over the math notes in this section. We've got a note about the associative property of addition and the associative property of multiplication. And what that does is it changes the order that you do things by changing the parentheses. This does not change the answer. The associative property does not work for subtraction and division. If you change the order with the parentheses, it will change the answer. The identity property of addition says that you can take any number, add 0 to it, and you still get the same number. The identity property of multiplication says that you can take any number, multiply it by 1, and the number is the same. Your assignment for lesson 2.7.1 is problems 2-67 through 2-71. If you're using your book, it starts on page 74.